Hi everyone, my name is Silvio Brandi and I'm a PhD student in energetics at Politecnico di Torino. In this presentation, I will provide a brief overview of my research activities. In the previous years, building complexity have risen. Greater attention was devoted to the satisfaction of occupants' comfort, while the progressive introduction of renewable energy sources and storage technologies raises several challenges to the management of building systems, also related to the interaction of the building with the electrical grid, which has become a key point to ensure grid stability and its safe operation. In this context, it required a new generation of controllers, capable to leverage building features to maximize multiple and often contrasting objectives, while automatically adapting to an evolving environment, influenced by several factors such as weather and occupant behavior. But how? Building-related data can be leveraged to enhance their performance thanks to innovative strategies based on artificial intelligence and optimization. One approach is represented by model predictive control. As the name suggests, MPC employs a dynamical model along with prediction of external disturbances to predict the future evolution of the system, identifying the optimal control action given an objective function. On the contrary, in a model-free approach, an agent directly learns the optimal control policy through a trial and error interaction without requiring the development of a model of the control environment, like deep reinforcement learning, which employs deep neural networks to map the relationship between the state of the environment and the optimal sequence of control actions. Despite being promising, these two techniques cannot be directly implemented in real buildings. In order to analyze their potentialities, a co-simulation environment was developed. This environment combines Energy Plus, a building dynamic simulation software, and an open-source programming interface developed in Python. This environment was employed to develop a model-free agent to control the supply water temperature to a radiant heating system of an office building. A sensitivity analysis on controller formulation and infra parameters was carried out for this specific case study, which is extremely common in the Italian building stock. The controller was capable to reduce energy consumption due to space heating while improving indoor air temperature control with respect to a classical rule-based controller. We developed several simulation models for different case studies, demonstrating the potentialities of advanced control strategies. In one of these, we filled a gap in the literature, providing a comparison between a model-based and model-free frameworks, showing how in ideal conditions they can achieve similar results, outperforming classical approaches. In conclusion, the developed environment allowed us to study the effect of advanced control strategies on building systems, highlighting their strengths and weaknesses, providing guidelines for their adoption to building professionals. Our future works will be focused in deploying this solution in a scalable way in real buildings through cloud infrastructures. Thanks for the attention.